Breaking! Welcome to another Narculus 2 production. Today we're going to be learning about the nth term test for divergence, another series test, okay, that can be used to determine whether or not a series diverges, and that's actually all it can do. So let's take a look at it, and we'll get started here. So again, the next test, this nth term test for divergence, can give us information about whether a series will diverge, okay? It cannot be used to test for convergence. It can only tell you if a series diverges. All right. So basically, what the test says is this: it says if the limit as n approaches infinity of a sub n, okay, the nth term of the series does not equal 0 or it does not exist, then the sum of the series from n equals 1 to infinity of a sub n has to diverge. All right. If the limit as n goes to infinity of a sub n is equal to 0, then the test tells you absolutely nothing about that series. You have to use some other test to determine its convergence or divergence. All this test is saying is if you take the limit as n approaches infinity of the nth term of the series and it doesn't equal 0 or doesn't exist, then the series has to diverge and you don't have to do any more. If you get 0, then the test tells you absolutely nothing. Okay? All right, so here's an example. I want to take this series and figure out if it converges or diverges. So the first thing we're going to do here, and it's always a good thing to try, is we're going to take the limit as n approaches infinity of 3n over 2n plus 5. So again, there's a couple ways you can do this. Take the limit of each individually. You get infinity over infinity. That's indeterminate. Okay, so you can use L'Hopital's rule, or you can divide by the dominant power. If you divide by the dominant power, you'd be dividing by n. Right, so that's 3n over n, 2n over n, plus 5 over n. And that would give me 3 up top in the numerator. In the denominator, it's 2 plus the limit as n goes to infinity of 5 over n goes to 0. That's 3 over 2. This limit does not equal 0. Since this limit is not 0, the series diverges by the nth term test. And that's all you have to say. Okay? We didn't get 0 for the nth term, the limit as n goes to infinity, so the series diverges. All right, let's try a few more, just so that you kind of see what's going on here. Let's try, figure out if this series diverges by the nth term test. Let's take a look. So we have 4n cubed. We're going to take the limit as n approaches infinity of 4n cubed over plus 2n over 5n cubed minus 3. So again, you could use L'Hopital's rule on this. You could divide by the dominant power. I'm going to divide by the dominant power. So that's 4n cubed over n cubed minus 2n over n cubed, 5n cubed over n cubed minus 3 over n cubed. That's going to give me 4 minus one of these drop out, make 2. 2 over n squared as n goes to infinity. That goes to 0, very small. That's a 5. 3 over n cubed. 3 over something really big is also really small. That's 4/5. 4/5 does not equal 0. So this diverges by the nth term test. Okay, let's take a look at letter B. Letter B, here's that factorial. The sum from n equals 1 to infinity, n factorial over n to the 5th power. Okay, so now, you did learn, hopefully at one point, that in terms of if you take the limit here as n approaches infinity of n factorial, n over n to the 5th, n grows faster for large values of n than n to the 5th, right? Okay, hopefully you learned that at some point. It was relative rates of growth. So this limit will be infinity the larger value is always on the top compared to the bottom. So again, this is not 0. So this thing diverges by the nth term test. All right. So again, this is a concept that you're going to need here, because if you want to use L'Hopital's rule on this, you can't use L'Hopital's rule because you don't know how to derive n factorial. Okay, and let's take a look at letter C now. So again, we're trying to use the nth term test on this. We're going to take the limit as n goes to infinity of 1 over n squared. So 1 over something really big is really small. It goes to 0. Okay, so I get 0. So the problem with this is, if I get the limit as n goes to infinity of this and I get 0, it's not 0. So this series is inconclusive. I don't know what this series does. It might converge, it might diverge. The one thing I do know is that this series does not diverge by the nth term test, because I got 0 for the limit. So I don't know if it converges or diverges. I don't know. What I'm going to have to do is I'm going to have to use another test. Okay? But right now we don't know enough tests, so I'd have to use another test to determine its convergence or divergence. All right? And that's how the nth term test works. It only works in certain cases again. Okay? It can tell me whether a series diverges in certain cases, but in other cases, it can't tell me anything. All right? And that's important. Okay? As always, thanks for clicking.